Okay, good. So, hello everyone. My name is Mohamed Sabri, and I work as a consultant in data science and everything related to data. Basically, I have a team in my team, people that are BI specialists, but we work as well and more focused on the sphere of operationalization. So mainly, I've done a lot of mandates as a machine learning engineer, where we had to tackle the deployment part, which represent a piece of the MLOps world. I worked with different company across North America. I'm based in Montreal, by the way, Canada, and worked with different organizations, large or small, where we're capable of either implementing MLOps environment or have the ability to do pure machine learning. And this helps me a lot to have like a good big picture of what's going on within businesses today when it comes to machine learning operation. My new book will be on sale very soon, called the Data Scientist Pocket Guide. So basically, in this book, I was able of defining and giving an interpretation of various concepts in data science in general. So the idea was to give a guidance to every data scientist, cover some machine learning operation in it as well. My agenda very quickly, knowing that we have only 30 minutes and then I have to take your questions. I will start by explaining why MLOps, talking a bit about the best practices, traps to avoid, and tips in MLOps, review of each module within your potential actual architecture, and then how to help you find weaknesses within your actual architecture. And if I'm talking like this, it's because usually when I get in a mandate in MLOps, people have already tried to do MLOps, but they struggle. So they say, hey, maybe it's time to see if we can get a consultant to support us in this. And that's where I usually get involved in companies. Why MLOps? Because first of all, deployment is not, MLOps is not equal to deployment. And that's something I hear a lot. I hear, oh, we're now in the phase of deployment. There is a big difference between just deploying models and managing and implementing an MLOps practice inside the company. MLOps is what make machine learning efficient. It's the last milestone that will make sure that everything you create will potentially help generate business value within a company. So very quickly, you probably know that, knowing that you attended this this conference. MLOps basically the ability to operationalize machine learning, the ability to reach a certain desired level of automation as well when it comes to basically managing the life cycle of your machine learning. And like I said, consider it as the last milestone within your machine learning practice. I usually use this comparison. There is two types of machine learning operation. There is the MLOps and there is the MLOps. The MLOps is usually when a company has that focus where they don't think machine learning operation. For them, they just did a bunch of POCs or prototyping, and they get to a point where they think, oh, actually right now we're gonna deploy. And then they deploy a couple of APIs, and then they start scaling their data science team, but they reach a level where they see that the ML operation is not efficient, because MLOps is not just about creating microservices. It's about as well scaling that. Is the tooling you use efficient and scalable? What's the level of automation you need? And machine learning operation, what's really where I really bring value, and any consultant in MLOps can bring value, it's its ability to design the environment, knowing exactly by asking the right questions, knowing exactly what do I need in terms of tooling, resources for a short, midterm, and long-term vision. Like I said again, and I love saying it a lot, machine learning operation or MLOps is not just about deployment. Again, there are so many DevOps things, environment management involved as well, automation that can be involved, tracking, monitoring that can be involved as well within a practice. People, they ask me a lot about what does it mean exactly, MLOps? What does it mean? What does it mean? For me, it's the easiest way to say it is like you adapt DevOps to the machine learning world, and that's what it is. So if you adapt DevOps, you mean you have continuous integration, you have continuous delivery here, and you add up something specific to machine learning that is called continuous training. Best practices. Usually people, and I used to do that mistake when I started in MLOps. When we want to do MLOps, we say, hey, you need this level of automation, you need automation, you need this type of tooling. You try to sell a Rolls Royce to someone who just need, I don't know, a very basic car to go from point A to B. I got a couple of customers. They don't need like that complex architecture because it doesn't fit with their needs. I have an e-commerce company, for example. Their short-term, mid-term, and long-term version in terms of machine learning in general is just deploying a couple of recommendation engines. That's it. They just want to develop, they deploy recommendation engine that they can update once in a while. That's it, that's all. So not that much of automation required, not that much of, actually no automation when it comes to pipeline, very few continuous integration. I mean, just the basics like model registry. And in this kind of cases, it's very easy. All what you have to do is have it like tooling and practices when it comes to the ability to do model registry, building blocks as well when it comes to experimentation, tracking experimentation, and then the operation side where you do the model serving. A little bit of automation in the model serving. So basically it will automatically fetch in the model registry for any new model or any update of the model, and then redeploy that update as a model serving that will do prediction. And that's it. That's all what we did. And they are very happy about it. We did it 2 years ago, and they still have the same system, and they don't want to go any further. So again, that's what you need to try to catch. What's actually the needs? What's the vision for machine learning in the short term, mid-term, and long term? What's the necessary level of automation? What's the scalability you're looking for? By the way, and that's normal for my case because I work a lot with the companies that are already, I mean, cloud-based with especially e-commerce sector or sector like fintech, tech companies, so they are already in the cloud. So 100% of my MLOps mandates are Kubernetes environment. I mean, that's something you need to have in your toolkit as an MLOps engineer or MLOps specialist. It's just a mandatory. I mean, even the tooling that exists today, if we talk about Airflow, we talk about Jenkins potentially, or Kubeflow pipeline, all those tools and deployment as well, like Cortex or TensorFlow serving, they are tended to be compatible or actually available for Dockering, so for being deployed in a Kubernetes environment. And usually the complex architecture had the chance to do 3 of them, like close to this one. Complex architecture is a lot of more of a long shot, requires multiple resources usually, but scales very, very well. And usually what I say to people is, when I say scaling, it's not just about scaling when it comes to the load that we may be facing or number of models. Scaling is especially relevant in terms of human resources, so people you need. Let's say you have an architecture in machine learning operation, but you know that in potentially 2 years, you might have more load in terms of machine learning projects, etc. And you realize that actually, if you want to sustain that in 2 years, it might require you to have potentially 25% managing your machine learning operation, which is a nonsense. So this means that your environment is not scalable. It's not scalable regarding the resources, human resources, the DevOps or MLOps engineers required. So that's something I always consider at the beginning to make sure that basically we are on track, and that later on my customer will be able to scale in a proper way. Because if you have the right desired level of automation, you will not need the 25 people potentially to manage. You might need like a quarter of that to manage that environment potentially. And that's important as well to keep in mind. So a good design of architecture will actually help you as a company save money and time later on. So yeah, I mean, components are very basic. This is from Google, but you will find Azure, they have their own approach, but I like the one of Google. It's easier without any tooling. So it's more focused on the purpose of the architecture. Like you probably know, you have the experimentation side, which is done usually by data scientists. Then you have the continuous integration. Continuous integration, consider it as Legos. Basically, it's like a little factory where people, they get in raw materials and the output is like Lego block. Lego block, they call it packages. Packages, why packages? Because we want to reuse those Legos to build up potentially castles. And the castles are automated pipelines later on. Because in the continuous the deployment or delivery, we will be using those packages or Legos to build up the pipeline that will be automated. The purpose of a pipeline is basically its ability to retrain potentially your model. So it will contain some ETL potentially, can happen, contain the ability to evaluate one or multiple models, and then the ability to push to a model registry. Something that I usually see there is a lack in it, a big lack in it in company. They don't know actually what to do exactly when it comes to that, is the ability to do monitoring, performance. And when I say monitoring, is the performance monitoring. The ability when you deploy an API or a microservice or a data stream containing a model, you want to know how performant is your model. And that's critical. I mean, if you don't monitor the performance, you have no idea if your model is performant or not. Is it garbage? Is it bringing real value to the company? No one knows if there is no performance monitoring. So it's a critical step. A lot of misunderstanding, because when you monitor performance of a model in production, it's not like when you monitor the performance of your model when you are doing machine learning. Because when you are doing machine learning, I mean, training your model, you use, I don't know, metric for regression, you use statistical metric for classification, but that's not relevant in production because you have nothing to compare with. So usually in performance metric right here, number 6, we use what we call business metric. Business metric can be, for example, if you are an e-commerce company, can be the conversion rate. How much we convert in terms of dollars or in terms of potential customers. Did people click or not click? Can be anything but more related to business, which is more relevant for performance monitoring. Then you have other components, but I don't have the time to detail all of them. Something very misunderstood is the usage of the feature store. People, sometimes they come to me and they tell me, hey, Mohammed, we don't have a feature store. We heard that a feature store can be useful, but feature store really depends on your use case. Sometimes if you have static features that are basically not changing through time, your feature store is useless. But potentially, if your features are changing potentially, or additional features can come up, then it becomes relevant to basically track them, capture them, and then use the metadata to potentially perform more data analysis or push it to your automated pipelines. So very important to keep in mind, this is not a bad architecture and this is not a good architecture. This is two architecture that can be useful depending on what is the need. Where do you foresee yourself as an organization when it comes to machine learning operation in the next mid-term or long-term vision? So how to define an architecture and environment in MLOps? Like I said, you have to know. You can be a consultant, you can be someone like an employee inside the company, doesn't matter. But the first thing you have to ask yourself and ask stakeholder is, what's the vision in terms of operation for machine learning when it on a short, midterm, and long term? That's very, very important, because with this you will be able to know how your architecture might have to scale, how scalable my environment has to be. Again, depending on type of loads. Sometimes even Kubernetes can be useless because you have a specific dynamic in, for example, the load when it comes to use, like potentially generating inference in production, that it's unnecessary. But that's very specific use cases. So it's really let's say it depends on which situation are you, but the trend today is to go within Kubernetes and virtualization. Another important question to ask as well is, what's the level of automation you're looking for? That's very, very critical, because basic use cases require very few automation. Automation can be costly as well. Costly, why? Because you need people to build that level of automation you want. I mean, if you go to large organization like, I don't know, YouTube, for example, they have bunch of machine learning models that are used on their platform. Well, due to the load they have, due to the number of models they have, it's an environment that I know that is close to 100% automated. I mean, they still have people developing models, but all the orchestration when it comes to operation in machine learning is close to 100% automated. As well, something to understand, and a question that to discuss with data scientists is, what's the retraining required in terms of machine learning? How much retraining do we do? And do we really need to automate that piece of retraining? And if yes, what's the rhythm? I mean, do we base that on a level of, do we base the retraining on the performance, on schedule, or both potentially? Because I know companies, they have both. They do have a schedule every 3 weeks or 2 weeks, and they have as well an automation, they have a trigger. The trigger where, based on the level of performance, it might be the performance of the machinery in production, it might be triggering potentially a new retraining from the pipeline. Something very interesting in MLOps is, MLOps, no one want to do it. Very straightforward. I have cases where you have the VP of engineering saying, hey, I think it's the DevOps team who should do it. And then, actually, they start usually with the data science team. They said, I think it should be under the umbrella of the data science team. And then people in data science are, no, we don't do this kind of things. I mean, we don't have the expertise. And then they say, hey, look at the DevOps team. It's their field. And then DevOps are like, oh, we don't know machine learning. We can't do it. So no one really want to take that. And no one knows how to do it later on properly, which can be an issue. Something else as well, have seen that case once, is basically some companies, they'll go with open source tooling, with coding, programming, automation, using code in MLOps, because they are willing to hire people. Others, they say, look, Mohammed, we don't want to deal with hiring. We really want just an environment where we can build up like our potentially models, and then have people with very basic training to do the deployment. Well, this use case, usually you go with enterprise solution or solution where you paid for, because it's almost completely managed for you. So really depending on the business case, you might decide for one or another. So those are really basic review of some questions that you might be facing in general. So now we can talk a bit about the traps and tips to avoid. Something that I see actually on 100% base in my mandates is when it comes to communication. Very basic thing, communication. MLOps requires communication, because there is a communication between MLOps, the data science team, because I mean, data scientists, they cannot push whatever they build to production, to CI. No, it doesn't work like that, because you'll see it. I can give you a case. This is a company that deploy machine learning models. They have recommendation engines. But the thing is, the data scientists, they created models that are too heavy. Like a model size saved in a pickle format that has the size of 5 or 6 gigabytes. It's not much, right? But still, it's a lot. Why? Because when you have such a model with this size, it's very hard after for your pods, when you work on Kubernetes environment, to start a new one. Why? Because each time it will start a new pod to basically scale, what will happen is that the model has to be loaded from the image. So what happened is that there is a huge latency in that load, because it has to load 6 gigabytes. And without talking about the bandwidth, by the way. So all this is not due to the fact that data scientists are not good, but the fact that there is no communication. People in data science, they don't communicate with MLOps, and MLOps team, they don't send requirement to data scientists saying, hey, this is what we should do for this case. This is what we are looking for. And the data science team should argue about what they think they can or is possible in potentially data science. So like I said, bunch of things that can be from filtering the input, like model size, like lightweight models. It's not always the case. There are different ways of solving the problem. Can be as well regarding the continuity of the data. And that's communication again. You need to communicate with the data science team to understand if the data that will be in production is continuous or not, because the data used for experimentation might be different from data in production. The ability, some companies, they like in MLOps to have, especially when it comes to deployment, to have a staging environment and a production environment. So staging environments are used basically to test models, test it in different ways, either regarding whatever performance or anything else, and then a production environment. Something else as well that impact the modeling production is the potential latency. I have cases where data scientists, they perform so much data manipulation on the raw data that it creates a certain latency. And this is as well something to discuss about, to understand better what is proper to deployment. Comes a lot with education from MLOps team to data science. So the data scientist, when he develops a model, he keeps in mind the requirement, he keeps in mind what will happen after he submit, and he push his work for potentially production. Yeah, I was saying one of the biggest weaknesses I usually find in people when they start building up MLOps environment is when it comes to model performance monitoring. I mean, you cannot deploy something and know how much is it performant. I know sometimes it can be hard, because sometimes it's hard to find the proper metric to measure the true performance of your model. But there is always a way, either directly or indirectly, to measure your model performance. One little trick when it comes to model performance is, I have a good case. Okay, so we deployed with the team a machine learning model. A good deployment went well. We have an architecture. Basically, I designed the architecture of the MLOps, and we did our first deployment. They integrated with their platform, and then after 2-3 weeks, the performance was very, very average. I mean, nothing extraordinary. And then one day, we didn't understand why. The performance was skyrocketing. For the upcoming 2 months. Even the performance metric was very, very good. And we were digging to understand why. They said, no, it's fine, it's working. I told them, no, I need to investigate, because that doesn't make any sense. A model that is doing average for a couple of weeks and then boom, starts like skyrocketing in terms of performance. Did the analysis of the data. The dynamic of the data didn't change much. I understand as well that the behavior of the user didn't change much. And then one day what I did is that I went on their platform as a user, and then I checked, and then I understand what was the thing, is that they basically changed the UI of the platform. The recommendation engines at the beginning were at the bottom of the page, basically. And then one day the UI team with the design, they decided to put that on the top. And that was the thing, is that they changed something within the platform that impacted the performance. So performance monitoring is not much easy as you might think, and it's very important to have one. I mean, even if you do A/B testing later on, you need to monitor the performance to understand how good are your models in production. So, yeah, I mean, next thing you can do, this is your mission, is that you can take sometimes in the upcoming weeks, for those that already are trying an MLOps architecture, and do me a favor and ask yourself, where are the weaknesses of my current architecture? Based on what we said, where exactly can I add potentially value? Where can I have a certain level of automation? How will it look like in a year or maybe 2, based on the project roadmap of data science? And all this will help you find weaknesses where you should potentially look for improvement, or potentially have new tools, etc. Yeah, that's it for me. I'm at 27 minutes. I think we can take question now.